Hello guys, in this lecture we'll study about the standard deviation of the stock return. The learning objectives for this lecture is we'll try to understand first what is the standard deviation of the stock returns, then how can we use the information about the standard deviation and the mean return to invest in a stock. We'll also see that if we have the same average stock return for two different stocks but different standard deviations, what will be the impact? We will see finally that how actually we can calculate the standard deviation using BA2 calculator, which is Texas Instrument BA2 calculator, and the Excel workbook. So the standard deviation comes or calculated after taking the square root of the variance, and variance is a measure of the return dispersion. So you have a stock in which you might have invested 5 years back and you held it for the last 5 years. Might be in 2016 the stock return will be different than 2017. It may be 7%. 2018 it can be 10%. 2019 the stock return might be 2%. So it means that it's a variable which can take any value. So there is a dispersion, there is uncertainty. So that uncertainty is measured through the variance, and if again we will take the square root of that variance, we'll come to standard deviation. The standard deviation is actually widely used compared to the variance because the unit of the standard deviation is the same as the unit of the average. So in from the perspective of the stock return, it is in terms of percentage for the standard deviation and for the mean return as well, because returns we calculate usually in terms of percentage. It is assumed that the stock returns have no normal distribution, so they are usually normally distributed with a very symmetric bell shape curve. And the property of the normal distribution is this, that if we know the mean or average and along with the standard deviation, we can reconstruct any bell-shaped normally distributed curve. So from the history, if we'll see, the return of the portfolio consists of the large stocks in New York Stock Exchange, large 500 stock from 1926 to 2015, the mean return have been 11.9%, and the standard deviation was 20.2%. Right? So what does it mean? What is the interpretation? So it's much easy to understand it by looking at the normal distribution of this of the return of this portfolio. So this is the normal distribution of the stock return of this portfolio, or in fact return of this portfolio. So the mean is 11.7%. If you go and see within the one standard deviation range, -1 standard deviation over here and +1 standard deviation over here, then you will see that just give me a second. You will see that if you will pick any return from the past return for this portfolio, the chances that that return will fall in between one standard deviation left and right will be 68%. So out of like all the returns, if you randomly pick, the chances will be that there are 60% percent chance that the return will lie between one standard deviation, both from the left and right. So if you go to the right, what was the standard deviation? It was 20.2. So you add that 20.2 in 11.7, which was the mean, you come to the +1 standard deviation. If you add to if you subtract the same standard deviation from the mean, you will come to -8.5. So this is one standard deviation range, both at the left and at the right. The two standard deviation, which is 52.1 on the right and minus 28.7 on the left. It means we multiplied the standard deviation with the 2, 20.2 with 2, we got 40.4. We added that in 11.7, we went to 52.1. We subtracted 40.4 from 11.7, we came to minus 28.7. So if you will randomly pick any return, past return for this portfolio, the chances that that return will lie between the two standard deviation from both on the left and right will be 95%. And the chances that any return will lie between three standard deviation is 9%. So there will be 1% chance only that a given return might be outside the range of plus and minus 3 standard deviation. So somewhere over here or somewhere over here. So this scene, to make some sense, if you see, if the standard deviation is big, this curve will be much flatter and uncertainty area will be much bigger. So for example, instead of say 20.2, if the standard deviation would have been 30%, then moving one standard deviation away from the mean means you have moved over 41.7 on the right, and likewise the range on the left will be also bigger. So the uncertainty increase with the bigger standard deviation. So look over here. This is a very simple example. If the mean is 100, these are the two normally distributed these are the frequency distribution or normal frequency distribution of two returns. So if it is 100 is the mean, 100%, the blue one has the standard deviation of 15. The other stock also have the same mean, which is 100%, right? This is actually not the 100%. Usually you do not have stocks with so much 100%, but this is a variable with 100 mean. So it's the same which mean which belongs to the blue line as well. But the standard deviation for the red variable, the variable which is represented by the red line is 30. In that case, you can see that the uncertainty area or the range of the standard deviation is increased, right? So it's much bigger. This means that higher the standard deviation, higher the uncertainty, or the higher the volatility. So now, if I will give you this question, that let's suppose if you have two alternatives, you can invest in stock A or stock B, and both are giving you the same return, which is 9%. So average return is 9% for both of them, but the standard deviation for the stock A is 6% and for the stock B is 18%. In which stock you will invest? So just pause and think about it. I think most of you agree that you will go with the stock A because there is less uncertainty. Most of the returns are basically near the mean, near 9% compared to stock B. Now, again, there is another alternative. Either you can invest in stock C and D, and the mean return is 7% for stock C and 11% for stock D, but both have the same standard deviation, which is 5% and 5%. Where you will invest? So this is very easy. The answer will be stock D, because with the same riskiness, with the same volatility, you might end up investing in stock D. In fact, you must invest in stock D because it is giving you higher return on an average. Finally, we will see that how we can calculate the stock standard deviation. So first we'll use the Texas Instrument PA2 calculator, and the key functions for this is data number, data key, and data key is actually the number 7 button on the PA2 calculator, and the stat key, which is number 8 key on the calculator. I'm going to show you the calculator in few seconds. The other way is to find it using the Excel functions in Excel, which is average we will use over there, and the standard deviation we will use over here, over there as well. But average we do not use while computing the standard deviation, but standard stdev.s, which means that it's a sample standard deviation which we will use in the Excel. So first let's start with the calculator. So say if you have these four returns, 26.4, and for 2009, 15.06, 2.11, and 16% in 2010, 11, and 2012 respectively. What is the mean return? I have actually already calculated it over here, but let me show you over here that how I will do it. So I have a BA2 calculator simulation with me, and I will use the second function and go into the data function. If you have already some data, you need to first clear it up. So press second clear, and then now you have only one variable, which is the return of this particular stock. Say this is stock X, right? So this is stock X. So if you have that, it will go into the X01. So the first return, which is 26, just give me a second data, second data, and the X1 is 26.46 percent, 26.46%. Enter. There is the Y1 is the other variable, so there is no other variable. The only variable is the stock return of this particular stock. So we'll go to X02. So press down arrow, X02, 15.06, enter. Then press down arrow, again press down arrow, X03, which is 2.11%, enter. You do not have to punch in the percentage. It by default it will take the percentage, enter, and go to the next one, X04, which is 16%, enter. Now press second and stat. You need to check the one variable function. So second enter, second enter, second enter, second enter, and here you go. You have the mean of 14.91, which is over here. Then you have the sample standard deviation, which is 9.97%. So you feed, like we fed all the numbers in terms of percentage. So the answer of the mean return is also in terms of percentage, and the standard deviation is also in terms of 9.97%. Finally, in Excel, you will simply plug in all these percentage number, and then you will use the average function. So is equal to average, and give the parameters, these numbers over here, enter. You got 14.91% is equal to this is the mean now, and the standard deviation stdev sample. Remember, it's stdev sample. You need to use stdev dot sample, and again give all the parameters, all these numbers as the number of these are the function values, and it will actually calculate. If it has calculated in terms of decimal, just convert it into the percentage. So here you go. you have 9.97 percentage. So this is how you will do the calculation for the to compute the standard deviation in Excel and BA2 calculator. Finally, let's we will wrap it up very quickly. In this lecture, we have learned what is the standard deviation and how can we use the information on mean return and the standard deviation of the returns to invest in stock. And also we learned how to calculate the standard deviation. I hope you like the video. Thank you.